Now let us discuss the halides of halogens, which are called interhalogen compound. Yes, these are, it sounds very typical, but the fact is that the halogens, when combined with their own group elements, the compounds formed are called interhalogen compounds. These compounds mainly are of four types: XX-, XX-3, XX-5 and XX-7. Now what we need to know is the X dash will always be a smaller halogen which comes afterwards, which will be having -1 oxidation state, and it will be mainly the X which will be existing in the +1, +3, +5 or +7 oxidation state. So X will be your bigger halogen, X dash will be your smaller halogen. Now when we say XX dash, what we need to know is, we know the fluorine, chlorine, bromine and iodine. See, what we know is fluorine can take out electron from chlorine, bromine and iodine. So we can have ClF, BrF, IF. Similarly, chlorine can take out electron from chlorine and bromine. So it is BrCl, ICl. And bromine can take out electron from iodine. So it is IBr. Now ClF is a gas, BrF is a gas, IF is also a gas, but what you need to know is BrF, bromofluoride, is a brown color gas, and IF is a very, very unstable compound. It's only seen by this, can be detected by the spectroscopy techniques. Whereas BrCl is a gas, whereas ICl and IBr, because of the iodines, are solids, and they are red and black respectively in their colors. When we say XX-3, it means the smaller halogen is able to take out three electrons from the bigger halogen. So it's mainly possible by fluorine and chlorine, because they are the only very strong oxidizing halogens we have. So it can take out 3 from chlorine, so it can form ClF3. It can take out 3 with bromine, so it's BrF3, and similarly we have IF3. Now chlorine cannot take out 3 from bromine because they are very close in their electronegativities and oxidizing power, but yes, it can take out 3 from the iodine, so it's ICl3. So we mainly have XX-3 formulas. In this we have mainly 4 compounds: ClF3, BrF3, IF3 and ICl3. ClF3 is a gas, BrF3 is a liquid, green colored liquid, whereas IF3 and ICl3, because of the iodine, are solids. It's yellow colored, IF3, and ICl3 is orange colored. This one. Now then we can have XX-5. In this, the smaller halogen is able to take out 5 electrons from the bigger halogen. Now taking out 5 halogen is only possible by fluorine, so it only form what we have 3 compounds in this category. It can take out 5 from chlorine, so it forms ClF5, 5 from bromine, BrF5, and 5 from iodine, IF5. All these are gaseous compounds, colorless gaseous compounds. And then we can have even XX-7. Yes, 7 electron, the smaller halogen is able to take out 7 halogens from the other halogen, and this type of compound is only possible between fluorine and iodine because of the large difference in their electronegativities, and that is why fluorine takes out 7 electrons from iodine and it forms IF7, which is a gaseous compound. Now let us understand their structures. Now for this you need to know, in case of XX-, like if you are talking about ClF, these are linear 2 atoms compounds, cannot form any structure. When we are talking about ClF3, like ClF3, we are talking about all of these are sp3 dehybridized with T-shaped structure. It's Cl, F, 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 and the 2 lone pairs are like this, like here. So it's T-shaped. Now when we are talking about XX-F, like we are talking about BrF5, what we find is these are sp3d2 hybridized with bromine here, and it's like 4 fluorines at the equatorial positions, 1 at axial, lone pair here. So the shape is called square pyramidal. Whereas in case of IF7, we know it's sp3d3 hybridized, and this is a pentagonal bipyramidal. So it's iodine in the center and 2 fluorine 5 fluorine at the equatorial positions, 1 above and 1 bottom. That makes it pentagonal bipyramidals with angle 72 degree and 90 degree. So these are your interhalogen compounds. Now you can know their preparation also. When chlorine and fluorine are taken in 1:1 equimolar ratio and heated, it forms ClF. But when the same chlorine is taken with excess of fluorine, it forms and heated at around 200 degrees Celsius, what we get is ClF3. Similarly, bromine with fluorine in 1:1 ratio forms BrF, but the same bromine with excess of fluorine forms BrF3. So it's like this, they can be formed. What you need to know at the end is that these interhalogen compounds, I have given you the states and the colors of these compounds. These interhalogen compounds are more reactive than usual halogens, like I'm talking about X2. The reason is because XX dash bond is weaker and polar. That's why they are more reactive. They easily breaks down into the different halogen species, and that's why they are more reactive than the normal usual halogen compounds.